Okay, let's have a look at the example 8 here, the last one. And again, the book makes these are examples out of the book, you guys. Okay? The, yeah, because it's that weird textbook, right? They make things way more complicated than it needs to be. It doesn't need to be near as complicated as it is. They are also nuts about sig figs, and so that's why those numbers are off a little bit. But let's just go through the problem here and figure out what's important. Is the 250 gram chestnut important? Of course, right? And warning bells right away. The mass should be 0.250, right? Got to be in kilograms. Chestnut with a hole drilled through its center is hanging from a long massless shoelace. What does that mean? It means it's not important to the question. Don't worry about it. Does the fact that, like, if you had 250 grams here, but the shoelace does have a mass, but that mass is distributed over that distance, does that matter? Yes, it does, because you've got a little bit of grams here, and a little bit there, and a little bit there, but the radius of all that mass changes as you go up the shoelace, doesn't it, right? Does that sound really complicated and hard? Yes, that's why they said massless shoelace. To get, well, that would be a calculus kind of thing. For sure. Drilled through its center is hanging from a long mass. Shoelace, the child spins the chestnut in a vertical circle, so vertical is important, at a speed of 4 meters per second. If the shoelace is 0.8 meters long, determine the tension of the shoelace at the top and bottom of the circle. So the radius of this is 0.8, and the speed is 4. Now, that when they say the speed, they actually mean the average speed, because at the bottom here, it's going to be going much greater than 4, and at the top, it's going to be going less. That's the average speed, right? Okay, so again, the book makes these way more complicated than it needs to be. Let's just find the weight force to begin with. Mass times gravity. 0.25 times 9.8, and I know you guys have this, so what is it? 2.45. Yes, that sounds very familiar. It is negative. For the time being, let's just leave it as a number. Let's leave it as a non-vector quantity. I need to start saying that, I think. A scalar quantity. It is the numerical portion of the weight force. The centripetal force, Fc, is mv squared over r. 0.254 squared over 0.8, and I'm sure you have this as well. 7 point something, am I right? No, 5. It's exactly 5, isn't it? 5 newtons. Okay, so go back to the picture, right? Weight force here, tension there, right? It's like, remember those questions in grade 11 where it was like, how much force does the engine have to apply to overcome friction of 10 newtons and also produce an acceleration of whatever, right? And you have to add the friction, right? Most people think, oh yeah, just subtract the friction. If you don't follow the formula, you don't get it right. Same idea here. The tension, if the thing is not swinging, the tension is numerically equivalent to the weight force, right? But there's also centripetal force that is acting up. So the tension in the string has to be the weight force plus the centripetal force, right? You need enough force to overcome weight and produce a centripetal force as well. So in this case here, the tension at the bottom is simply, well, let's just go like this. 2.45 plus 5, or 7.45 newtons, right? And that's at the bottom. And the tension at the top, let me draw a new picture here. Because the weight force is down, because the centripetal force is down, weight force provides some of the force for the centripetal force, so the tension can be less. So it's simply going to be 5 minus 2.45, which is 2.55 newtons, right? They make it way more complicated than it needs to be. Okay. I think we're based on what I saw today, I think we're in reasonably good shape. I'm going to give you another period though, to just make sure. I'm going to give you, there's been a request for a few more problems, so I've run them off as well. For me? I don't think these do. You want more bank curve ones? Yeah. Okay. I know there's some in the textbook. that I did already. No. I'd like to another. Okay.
Different.
Why?
Franny, was it too different or was it just the right amount of difference?
What?
Yeah? Well, and the next time you do it, it won't be. Okay, so you've got here, you've got a problem pack there. There's only like 9 questions. There are answers there. There was a request one year for more multiple choice questions because they do pop up on tests, and that's because, as I've seen on the university exams, that's where they are. So I found some multiple choice questions, which do have answers as well.
Do these have theory in them as well?
They have theory in them as well, yes. Okay, so there's a wide variety of questions there. I'm not saying you must do them all. I'm just providing them for you, and you manage your own study. There are questions in the book as well, if people are looking for more banked and unbanked. In the textbook, those appear on page 226. And in fact, likely on this overhead here, there's likely a... No, this is the stuff from yesterday.